So today we are going to study traveling salesman problem using Bronson bond method. So first we need to find out the shortest path. So shortest path that goes through all the vertex once and return back to the starting vertex, right? So the adjacent matrix is given. Now from this adjacent matrix we will be finding the row minimum first. So the first minimum value for from the row 10, second row minimum value 2, fourth row minimum value again 2, third row minimum value 3, next last row minimum value, that is 4. So these are the minimum values that we are getting from the rows. Now next what we need to do is we need to calculate the total reduced cost when we find it out the minimum value from the row. So the reduced cost total here is 10, 4 plus 3 is 7, 7 plus 4 is 11, right? So 11 plus 10 is 21. So that is the total reduced cost. Reduced cost that we got from row by finding row minimum, right? So here what we will be doing now, we will be subtracting this value, that is the row minimum, from the corresponding values of the matrix. So here we will be subtracting 10 from 20, that is 10, 10 from 30, that is 20, 10 from 10, 0, 11 from 10, that is 1. So like this we will be subtracting 2 again from this next row, and so on till all the rows we have subtracted from the minimum values, corresponding minimum values, and then we will be seeing what reduced matrix we are getting. So we find out the minimum values, and after finding out the minimum values we get this reduced matrix when we subtract it from each of the rows. So now after the minimum values from the rows we will be finding out the minimum values from the columns. So column first minimum value 1, column second minimum value that come out to be 0, column next minimum value that come out to be 3, column next minimum value that come out to be 0, next minimum value come out to be again 0, right? So here these are the values for the column minimum. Now what is the total? So the total value that come out should be, that is 4. 3 plus 1 is 4. So this is 4 is the reduced cost that we get from column minimum, right? So now we need to add these two costs, and before that what we need to do is we again need to subtract that minimum value, that is 1 we got from the first column. So we will be subtracting from the first column 1, that is 12, 0, 15, 11. Next one we have to subtract 0, so no change. Next one we have to subtract 3, right? We have to subtract 3. So here in this case what will be the changes? Here it will be 17, 11, then here 12, here 0, right? Like this we will be subtracting two columns because others column is having the value as 0, so not required to change anything. So now we will see what will be the our reduction matrix after subtracting the column minimum, right? So here you can see what we are getting. So what we are getting is we are getting the reduced matrix after finding out the column minimum. So here 21 cost we got from the row minimum, and by finding out the row minimum from each of the rows, and from the column minimums we got the cost as 3 plus 1, that is 4. So total cost, reduced cost is 21 plus 4, that is 25. So now we will be solving this using branch and bond. So we will be using a state space tree for that. This is a state space tree. Here the upper bound is infinite. No upper bound is given, so we are taking it as infinite. Then the first node, we find out the reduced cost as 25, that is for the first matrix. Then we will find from the cost from the 1 to 2, 1 to 2, 1 to 3, 1 to 4 and 1 to 5. So here when we are finding the cost for 1 to 2, so what we need to do is we need to make all the first row as infinite. So here we will be making this first row as infinite. Now we want to go from 1 to 2, so here second column as infinite. Now what we are saying that we are not able to move from 2 to 1, so 2 to 1 also should be infinite. So this will also be, this is 2 to 1, so this is also be infinite. So we will see in the next matrix how we are setting this infinite. Yes, so here we have first as infinite, second column as infinite, then 2 to 1 is also infinite. So now after making it infinite, we found that most of the columns and rows are containing zero value. So here the cost reduction is 0 only. The previous cost reduction was 25, and the cost reduction of 1 to 2 in the reduced matrix. So we will move to the reduced matrix and we will check what is the cost for 1 to 2. So here in the reduced matrix, the cost for first one and the second column, so first row and the second column is 10, right? So here what we'll be doing is we will be taking 10 as the cost of 1 to 2, then the reduced cost that we got from the first matrix, that is 25, and the reduced cost for the matrix now that we are having, so it is 0, since all the rows and columns contain 0 value. Now the next one, so here what basically we want to do is, now we are again want to find out the value for 1 to 3. So 1 to 3 we are finding. So for 1 to 3, what basically we are doing is we will be making the first row as infinite, and 1 to 3 means third column as infinite. Now again 3 to 1 is not possible, going back from 3 to 1, so 3 to 1 will also be infinite. So now if after this we will be finding the minimum value, so from the minimum value from the first column is 11, second column the minimum value is 0, third one it is infinite, then the next one it is again 0, the next one it is again 0. So this side also from the rows, if we will be finding the minimum value, so this is infinite, so here it is 0, 0, 0 and 0, so no changes in the rows, but in columns what we need to do is we need to subtract 11 from this first column. So first column we have to subtract 11. So after subtracting, what will be the case? 1, then infinite, so first one is already infinite, infinite, 12 minus 11, 1, then again infinite, then 15 minus 11, so that is 4, and then 11 minus 11 is 0. So other is, there will be no change in other rows and column because the cost is 0 or infinite, right? So now the reduced cost that we got now is 11, and the cost we get from the first matrix, that is 25, and the cost that we are getting from the matrix, that is we are getting the cost 1 to 3. So 1 2 3. So we will first erase all this and we will now check. So what is 1 to 3? So first row and third column, so it is 17, right? So here we are writing 17, cost of 1 to 3 is 17, then reduced cost is 25, and the reduced cost of the current matrix is 11. So the total cost for 1 to 3 is 53, right? So like this we will be writing this reduced cost on the state space tree. So the state space tree contains the reduced costs of 1 to 3, the cost of, not reduce, cost of 1 to 3 as 53. So now once now we are able to do this, so we will be now skipping this part 1 to 4 and 1 to 5. So now we will be easily able to find out this, because 1 to 4, what infinite we want to make, we will be making all the first row infinite and the fourth column infinite, also 4 to 1 as infinite, and we will be finding out the minimum from row and column, and then we will be calculating the cost using the formula 1 to 4 cost plus the reduced cost and the reduced cost of the current matrix, right? So after this, what we need to do next? So we will be exploring the minimum cost node. So here the minimum cost node is 25. So we will be now exploring further 25. That is, we will be exploring the node 4, that is having the minimum cost as 25. So we will be directly moving to the next node, that is after 1 to 5. What we will be doing is we will be exploring 4. So we can go either from the 4, where we can go. So from the 4 we can either go to 2, we can go to 3, we can go to 5, right? So now we have to find out the cost for 4 to 2, right? So 4 to 2, we have to calculate the cost for 4 to 2. So what is 4 to 3 and what is 4 to 5, right? So here we will be using the matrix of node 4 to find the cost of all the nodes. So first we consider the path from the vertex 4 to the 2. We will be making the fourth row and the second column is infinite, so we can't move back. So 2 to 1, uh, so we can't move back, that is above this 4 what is having 1. So 2 to 1 also we need to make as infinite. So how we will be doing that? For that we have to check the node 4 matrix. So this is a node 4 matrix. Now since we need to move from 4 node, so we'll be using this matrix. So this matrix, now what we need to do? This matrix we have to make all the fourth row as infinite, and then we need to move to the second, so fourth row and second as infinite. And then what we need to do is we need to mark 2 to 1 as infinite, because we can't move back. So from 4 to 2, if we want to move from 2 to 1, so that is also infinite. So here 2 to 1 will also be infinite. Now what we need to do, we will be finding out the minimum values. So here the minimum is 0, here it is infinite, here it is again 0, here again infinite, and again 0. And for the row, if we will be checked, so we will be checking infinite, 0, 0, infinite, 0. So the reduced cost is 0, and the previous reduced cost is 25 that we calculated. So now what we need to do next, we need to check out the cost for 4 to 2. 4 to 2. So what is the cost for 4 to 2? That we need to check out in the reduced matrix. So we will move to the reduced matrix, first reduced matrix. So in this case we check that 4 to 2. This is 4, 0, 1, 2, 3, 1, 2, 3, 4. Fourth row and second column, so that is 3. So here the reduced cost is 3. No, not the reduced cost, the cost of 4 to 2 is 3. So we will be adding 25 plus 3 plus 0. So what it comes out to be? It comes out to be 28. So this is the cost for node 4 to 2. I hope it is clear how we are finding out. So now you can check out this slide. So here what is the cost for 4 to 2? So that is 4 to 2, the cost is 28 as we have calculated right now. Now again, if we want to move from 4 to 3, right, what we need to do is we need to move from 4 to 3. So in that case what will happen? We will see that case. So we are having 1, then we are having 2, then we are having 3, then 4, then 5. Now we are creating the state space tree, further exploring the minimum. So this one is having the minimum cost, so we are exploring this 4. So 4 to 2, we already calculated the cost is 28, then 3, and then 5. So now we will be calculating for 4 to 3. So 4 to 3 means what? We need to make fourth row as infinite and third column as infinite, as well as we want to make 3 to 1, because we can't move back directly 3 to 1. So 3 to 1 also we will be making as infinite. So after making it infinite, these things where we need to do, so we will be doing in the node 4 matrix. Node 4 matrix. So we will now move back to the node 4 matrix. So this is the node 4 matrix. So in the node 4 matrix, what we are doing is, in the node 4 matrix, first we have to make infinite 4 row and third column, right? Then what else? So we can't move back to 3 to 1. So 3 to 1 as infinite, right? Now what we need to do, we need to find out the minimum. So minimum here, everywhere the minimum is, here it is 2, here it is infinite, here it is 11, here it is again infinite, here it is 0. And now what we need to do is, we need to subtract this minimum value from the row. So what will be the resultant? So we will be just changing this third one and the fifth one, because rest are having infinite and 0. So third, only this will be changed to 0. It will be changed to 0, and this here on the fifth one, this will also be changed to 0. So next, when we will be finding out the column minimum, so this side we will get 0, this side infinite, this side again infinite, infinite, then this side again 0. So only two values are there, so we will be adding this, that is 13. So our reduce cost of current is 13. So the previous one was R was 25, that is the first matrix, that was 25. So now what we need to do is, we need to check out the cost for 4 to 3. So we will be checking the cost for 4 to 3. What is the 4 to 3 cost? Because we want to calculate the cost for 4 to 3. So here 4 to 3, fourth row and third column. So this is the node 4 na, so we will not be checking this, we will be checking the first matrix, reduced matrix. So here 4 to 3, fourth is this one, and then this one, so this is 15. So what we need to do is, we need to write here 15. Now we need to add all these 3. So 13 plus 15, so that is 28, then 28 plus 25. So here what will be the total cost? So here it is 53. So 53 is the cost for 4 to 3. So we will now check out this, and then we have to find out the last cost, that is 4 to 5. So that also we are doing from the this matrix, that is node 4 matrix. So what is 4 to 3? So 4 to 3 cost we get as 53. So here 4 to 3 is not there. So 53 is more than the cost of 28. That is the first 4 to 2. So we will not be exploring 4 to 3 now. So here now 4 to 5. 4 to 5 the cost is 36. So 36 is again more cost. So now we'll compare the cost of all the leaf nodes, and the node with the cost 28 is the minimum one. So node with the cost 28 can be further explored to the node 3 and 5. So where we got 28? So we got 28 in the node 4 to 2. So 4 to 2 is having the minimum cost, that is 28. So we will be further exploring the node 4. From 2 we will be exploring, right? So here 1 to 2, then 3, then 4, then 5. We find it out that 4 is minimum. From 4 we find out that 2 is the minimum one. So from 2 again we will be exploring 3, and we will be exploring 5, and then we will be checking the minimum one, and the minimum will be the path that we got as the shortest. So let's explore what is the cost for 4 to 3 and 4 to 5. 2 to 3 and 2 to 5, sorry. So 2 to 3 and 2 to 5. So what is the cost here? For 2, now if we want to find out 2 to 3, so here the cost is 52 for 2 to 3, and 2 to 5 it is 28. So what we will be doing is we will be taking 5. So what is the path we traverse? So now from 5, first we traverse 1, then after 1, 4 we find out to be minimum, then we find out 2 to be minimum, 4 to 2, then 2 to 5 is now minimum. We have seen that the cost 2 to 5 is the minimum, that is, what is the cost for 2 to 5? That is 28. So now since 2 to 5 is the minimum, that is 28, so we'll be taking 2 to 5. Now next from 5 what we are doing is we are further exploring from 1 to 4, then 4 to 2, then 2 to 2 to further 5, right? So now here what is remaining? So that is 3. So we'll be checking out the cost for the same. So what is remaining? That is 5 to 3. So here 5 to 3, what is the cost? So it is how to be 28. So here we will be using the matrix for node 5. So from wherever we are traversing, starting the traversal, so that matrix we will be taking. So here we can calculate 5 to 3.